All right, please put your hands together for our next speaker, Aaron Guzman.
Thanks, Johan. Glad you guys can make it. This is going to be don't get caught in bed. So it's I'm hoping it's going to complement the keynote. A little bit more low level and some technical aspects to it, defensive and offensive wise. So my name is Aaron Guzman. My Twitter is up there. Usually tweet out my slides or research, whatever I'm working on, whether that's within car hacking, mobile app space, or embedded or IoT as well. I'm from Los Angeles, so right now it's literally the middle of the night, 1:20 in the morning. I'm definitely a big pizza fan. Late last year, I set out to find some bugs and apps like Domino's, and I ended up getting free pizza. And everywhere I go, usually, I try to get pizza from, if they have a Domino's or a local like pizza place, I definitely try to order. So last night was the speaker dinner, but probably I'll be here for the weekend, so probably Saturday or sometime this week I'll get to try Gothenburg's Domino's or whatever you guys have here. I'll figure it out very, very soon. So currently at SecureWorks, I used to work at Balkan and Linksys. I used to lead the security for the networking part of Linksys and Balkan. So that's like the webcams and the Linksys routers, as well as I was on the Wemo team. I know Steve briefly talked or touched upon that. And we'll get to more of those kind of painful stories later on. I'm currently a board member for OWASP Los Angeles, as well as a board member for Cloud Security Alliance, Southern California, previous president as well. Been involved for about 4 years in the Los Angeles area as far as the community is concerned. I also lead a project called the Embedded Application Security Project for OWASP, and I also contribute to IoT Project and the mobile testing guide as well. I've spoken at DEF CON IoT Village the last couple years, DerbyCon. Hopefully I'll get to speak about some car hacking research. I actually submitted only to DEF CON and Steve's conference, so let's see what happens. It's on Subaru, by the way, so should be fun. Not a space that's been researched. I've also talked at Hackfest in Canada, RSA. I also co-organize AppSec California, so that's all the OWASP chapters for California. We get together. We have a conference in Santa Monica on the beach last weekend of January, so if you guys want to get away from the winter cold or the cloudiness, come over to our conference. I run the volunteers, by the way, so if you need a free entrance, you're just willing to donate some 3 hours of your time, I can get you guys in for free. Shameless plug, but it's fine. I was an editor for a book called Practical Internet of Things Security that published last year, and I'm currently writing a book called the IoT Pen Testing Cookbook for Packet Publishing. So that's everything from hardware hacking to firmware reversing to mobile reversing, web, as well as best practices on how to fix those problems in the space. So again, there's never, talks and research is never good when it's only just bad. You have to have the good and how to fix things as well. I also have a couple CVEs under my belt. Such a painful process. So let's get started. So embedded device and technology. I mean, again, it kind of seems like the trend is IoT. Generally, embedded is IoT, except much smaller, compact devices. Back in the 90s, they've been around for a while, obviously, but now they're just network connected with different types of protocols. Whether it be wireless protocols, BLE, Wi-Fi, Zigbee, Z-Wave, LoRa. Loads of them actually out there. So I'm going to be talking about more, again, from the offense and defense perspective, but as well as, what the embedded is consisted of, like connected vehicles. We know about, the different inputs and outputs, infotainment systems. You got the CAN buses. You got, it has Wi-Fi as well, depending on, the vehicle. Medical devices, wearables, implantables. You have smart cities. You guys are fairly familiar with this type of technology. And some of the threats that kind of happened last year and some of the big things that are of main concern or it's kind of affected the industry moving forward and kind of almost immediately for some devices, but taking a step back and talking about things like medical and last talk, the keynote talked about St. Jude. Crazy enough, a week and a half ago, emergency surgery my grandma had, and she had a pacemaker from St. Jude installed. So more research on that to come. Hopefully nothing too crazy. So St. Jude was acquired by Abbott Laboratories, which actually got fined a huge amount. We'll get into that. But medical and IoT and embedded, they're all the same problems as as in the keynote you saw, hashes being dropped in a command shell. But there's more as far as where this data is being stored, how it's being transmitted, and it's usually clear text communications, unfortunately. And there's again CVEs from last year to reflect those findings. And then consumer and commercial and ICS devices, again, same patterns. You have hard-coded passwords, firmware in the firmware, and we're going to discuss how that gets in there, as well as command injection vulnerabilities. You can execute operating system commands, and then Mirai. It's funny, I was at a conference last week, and only one person out of maybe 100 people knew what Mirai was. Very, very shocking. So who's familiar with Mirai? Before I say that. Okay, you guys are familiar, awesome. And as you may know, Mirai was huge, or is huge, and it continues to sprout out to a various number of different types of IoT botnets. And that's because Mirai source code is free, it's open, everybody can view it and make changes. And it's very, very simple how it works as far as Mirai is concerned, and how you can also tweak it. But usually, if a device is rebooted or reset, all you got to do is click that button from the 400-pound hacker and just regain them. You regain them like another one. Just keep going, going. Literally, just automated scripts that run. And everybody does this. There's a few researchers I know who constantly run Mirai code. But these different strands of IoT botnets are Hijame, Brickerbot, and Perserai. These are just a few of them. They're called vigilante type of IoT botnets, where they either shut down the vulnerable services, Telnet, FTP, things like that. And you have others like Brickerbot, where it literally bricks a device, denial of service of device, kills it completely. And then Perserai, you have those types of IoT botnets that take control over IP cameras and DVRs, a different subset of IP cameras and DVRs that are P2P types of devices. So we'll go to P2P types of devices. It basically creates a backdoor in your network, traverses your NAT via stun and turn servers. So you don't have to port forward for the consumer space. You don't have to port forward, let's say, any configuration for to view your camera feeds. So it's usually for voice over IP types of devices, or even doorbells, for example. Any IoT device usually does that for remote access, because how often do you have to open up ports anymore? Now they just open them up internally from your network, and now you have a port open and traverses your LAN. So much for firewalls and routers as far as your perimeter is concerned. I'm not sure if you guys got the 400-pound hacker joke, but I'm not going to get into it if you don't know it. So essentially what we have is Internet of Pwns. I mean, thousands and thousands of devices. And again, it's very, very simple, preaching to the choir here. But how they find, or attackers find, or researchers find these bugs and vulnerabilities and exploit them is through some sort of methodology, a firmware exploitation methodology. You obtain the firmware in a number of different ways, whether that be through OTA, whether that be through JTAG, UART, whether that be through the vendor's website or through a mobile app as well. You can see hard-coded URLs as well. And then once you have the firmware, you can basically statically analyze and extract the firmware contents. And from there, you can then mount the file system. So whatever the file system would be, there's a number of different kinds, and we'll go through them right now. Analyze the contents, and then also do runtime analysis and dynamic analysis as well. So like burp and zap type of scans where you don't have to have the device in hand, but you can emulate via QEMU, for example. Who's heard of QEMU before? Okay, a few. Who has reverse engineered firmware before? Awesome, okay. How about web? Anybody web people? Okay, we got a mixed crowd. So as far as the firmware exploitation methodology, let's do a quick demo. I got 3 live demos, so crossing my fingers they all work. One of them I'm even VPNing to my home. So we'll see how this goes. Shouldn't have done that. Okay. All right, guys, so if you guys can see that. Is that clear enough for you guys? Big enough? Okay. So we have 2 pieces of firmware. I'll go through one right here. What I'm going to demonstrate is basically extracting a firmware image using something called binwalk. Anybody heard of binwalk before? Okay, binwalk-e, general. Super, super simple. It's not always this simple, but generally in consumer space, it is this simple. So I extracted the firmware contents. Now I'm going to change the directories into the firmware contents. And now let's see what we have here. We have other firmware images, or they meant to partition it. Now let's go ahead, since I know where, I'm looking for the root file system of the embedded device. So this is actually an IP camera, one infected by Mirai, as a matter of fact. So let's bin walk again. Now let's change directories into that image, and it's using a CramFS file system, root file system. Now let's just check for hard-coded credentials. What do you know? We have, let me bring that up here. We do have some hard-coded credentials here. And this is something that the user can never change. It has to be directly from the vendor, the OEM, and we'll get through the supply chain. And even sometimes the OEM can't change this value. It's hard-coded by, basically, they're called ODMs. And again, we'll get through those in a minute. So simple stuff, right? Not too hard. Bin walk's a free tool. Again, obtaining the firmware it's half the battle. And I have a little link here for you guys. If you're not familiar with any other type of firmware tools, there's definitely a lot more. Just bin walk's the easiest and go-to. So there's other ones that actually do the firmware emulation for you. Actually set up QEMU so you can do dynamic analysis, the runtime analysis using something like GDB, and do breakpoints, and that's how you find heap and stack overflows, for example. Oh, that was my live demo. So the supply chain and how these devices are created. Okay, you have a board, right? You start with the PCB, and then you have a BSP, board support package. It's exactly that. The packages that support the board that you're deploying or the device. So you have peripherals, you have Bluetooth, whatever, Zigbee, Z-Wave, you have UART, HDMI. And usually these are, Broadcom, Marvell, for example, are pretty common. If you look on your Wi-Fi drivers, usually see Broadcom, even in Android devices. But they're definitely huge in the IoT space as well. From there, you have your ODM, original device manufacturers. And this is kind of where the problems stem out for IoT, and I don't think it'll ever get resolved unless you have some sort of model like Apple, where it's very closed. Because the margins are so thin in these devices, you have a cent for a Wi-Fi module, and you have 20 cents to $1 for a TPM, a secure element. So obviously, those don't match up. Depending on the regulation, of course, that might make sense, but it's not super, super common. But the ODM here basically provides either a binary of the root file system, or even, let's say, subset of, let's say, USB, for example, like NetUSB, sort of NetUSB, ROM pager, things like that. They're basically outsourcing outsourcing and exposing an SDK to the OEM. Now, on top of the ODM, you have the cloud service provider, Amazon AWS, for example, Microsoft Azure. But what's funny now is you have the BSP board support package makers also teaming up with cloud service providers like Marvell is working with Amazon AWS and provides AWS SDKs as well as Marvell's SDK. So again, these are different code bases, different teams. And then same thing on Microsoft Azure. They're teaming up with Intel for their products and their IoT development kits. So that way they can have, again, remote access. That's the point of IoT. That's the point of this whole trend. So as far as the ODM space right here, Zhongmai, this is the company, the ODM, that created or was responsible for Mirai. Chinese ODM, and then basically the OEMs rebranded, and then there's also resellers who rebranded, and it kind of creates a whole chain where it becomes unrealistic to basically backport even security flaws. Again, because how are you going to go from, let's say, a Nest here to, and again, these ODMs as well are like 10 people from Taiwan or China as well. I've been on the calls with these teams, and if you ask what type of security controls are in place for firmware of the device itself, their answer is they have 128-bit encryption. They're good. A self-signed certificate, by the way. So they're small teams. They last between 5 to 10 years even. They branch out into other small companies. It's quite funny to see them evolve. We usually have bigger companies who partner with known ODMs, more established ODMs, but let's say, again, it's basically faster to market. So the OEMs choose the cheaper ODM to create a software stack, and the ODM just supplies their name and maybe a couple different features. But again, backporting from OEM for a security bug over to a bug that starts either from Broadcom or even from the ODM standpoint. Not only are there a lot of dependency issues, but there is no, let's say, streamline for communication, and even as far as drivers are concerned, to make sure there's consistency and there's testing. But not only that, well, that's the biggest pain point. We'll get into more in just a bit. So as far as the common operating systems that these devices run on, and again, I'm speaking low level as far as embedded only at this point. So you have embedded Linux, probably the most common. You have Android that runs off of that. You have legacy kernels. I've seen 2.6 even being deployed as Kickstarter projects for even IoT home security devices, which is funny enough. You have real-time operating systems, RTOS. Anybody heard of RTOS before? Okay, a few. It's usually, for the most part, it's a commercial licensed, but you also have a free RTOS. So I gave the example of Marvell working with AWS. Marvell actually creates the operating system and uses free RTOS, and then connects the AWS SDK together, so the OEMs basically just patch together their code bases and merge it. It sounds odd. But again, RTOS, there's mostly commercials, aside from the Marvell example. You have VxWorks, QNX for BlackBerry, MQX, you have Green Hills. And then you go to the Windows embedded side. Not a big Windows guy. But usually they're point-of-sale systems, POS. Not the POS you're probably thinking about, but it really does relate. But also medical devices. Medical devices are run Windows XP, Windows CE, but they're still a Windows embedded version of those operating systems. And now this is relevant for, again, medical, I stated. Now, medical did get affected. Windows embedded medical devices did get affected by WannaCry. So you got to think about that as far as the attack surface and the different types of platforms. And I guess, I don't know if I'd rather go with an old Linux kernel or go with a Windows embedded type of operating system. Well, I know what my answer is, but I mean, think about the attack surface here. But then there's Windows IoT Core. And again, I mentioned that with Intel. Intel's working with Azure, but it's called Windows IoT Core as the platform that they're working on, the operating system. So there's plenty to choose from, but the most common, especially in the consumer space, is embedded Linux. And we'll speak more towards embedded Linux as far as the presentation is concerned. So the basic contents of embedded Linux, you have a bootloader, whether that be U-boot, Red Boot. You have the kernel, whatever Linux kernel it may be. And it could be custom kernels as well. And then the root file system, there is, CrimFS is one of them, SquashFS. There's loads of them out there, but those are pretty common. There's definitely more. But the root file system is where you have your configuration settings, your configuration files, your service files, things of that nature. And again, you could always partition out and separate out as far as the firmware content and the feature is concerned. So let's say you only want to have the services in one sort of binary image, and then only have custom services in another binary image. So similar to what we have here, they have U-boot in one directory here. They have the web, they have the root file system, they have user, and they also have a custom. So you can basically, and this is how like ODMs send their products or their images, their SDK, again, as a binary over to an OEM. And OEMs, they're not going to reverse engineer an ODM's code base. And we'll get to that in a bit. So some best practices we'll touch upon today, and this kind of stems off the project that I lead, is buffer and stack overflow protection, injection preventions, firmware updates and cryptographic signatures, security extensive info and data, and how to store that as well, identity management, embedded hardening and tool chain hardening as well, debugging code and interfaces, TLS, usage of data as far as privacy and where it goes, third-party code and components. And I think one of the most important aspects of creating secure embedded devices is starting with threat modeling even. I mean, basic threat modeling would, if any of these ODMs did basic threat modeling, a lot of these problems with, the easy-to-find Telnet, cleartext, FTP, simple flaws in design would be thwarted right there in design stage, and even before deployment. And again, we'll speak to a few of these, or many of these, and not all of them, and I'll give some examples as well. Even with threat modeling, I haven't seen a good threat model IoT, talk or slide or anything like that. So got something coming for you guys. And here I have the Git book of the project that I lead. And again, I like to keep it updated. So if any of you guys have feedback or want to contribute in any way, and cool thing is that we have people from PCI working on it, people from universities over in the States, and even over here in the EU as well. And also the FTC is actually looking at using this documentation to point negligent manufacturers when there are flaws in these areas. So it's a good step forward. And what it is basically provides low-level C and C++ examples, a non-compliant example and a compliant example, and then why it's non-compliant, and then how, why this is compliant, what makes this safe. So it's not just, these basic design principles that everybody talks about, and where there's no examples of where a developer who's been writing C and C++ for 15, 20 years, never had any security training, and you give them, you give them a PDF, and you give them these principles, they don't know what that is, they don't really care even, they don't have no incentive as well. But when you put it in their language, you put it in their world as far as their build systems and C and C++, their languages, they don't have frameworks like the web does where auto escapes, or outputting codes even, let's say JavaScript, for example. They don't have those types of frameworks. So again, this project is based on helping or providing practical solutions that developers can work on and prevent and mitigate these top easy vulnerabilities that can be prevented. Just walking through buffer and stack overflow protection. This is, again, preaching to the choir. This has been something that's been spoken about years and years and years. Nothing new. Prevent dangerous C functions. Who's heard of that before? Okay, yeah, so many of you guys have. And here's like a simple find command. If you have the source, you reverse engineer the application to find string copy and string length and discover how much of those appear within the code base, and you can find out what you want to target as far as an attacker is concerned, and even from a defense perspective, how you can check those bounds and validate those inputs, for example. And then use safe equivalents like gets and fgets. And there's definitely a lot more, and the guidance document, the Git book that I have, provides those solutions and some considerations as well, and also references where in the wild and in the industry, devices and manufacturers and embedded software has been compromised due to some of these problems here. Now, enable stack protection in build systems. Who's heard of build root before? Awesome. You guys are embedded guys. There's only a few. Who's heard of Yaak? Awesome. Sweet. That's surprising. Usually it's the other way around. So these are embedded build systems. This is how firmware is made, developed. Basically, a menu configuration. So, for example, enabling stack protection in build root looks like this. Simple. It's literally a little star here. And again, build root up here. But if they only knew how simple it was to input some sort of a stack canary, a randomized integer into the stack, and if modified, it would fail. Something like CSRF protection. Think about it like that if you don't know what stack canaries are. But again, pretty simple, right? I mean, it's almost no excuse. But you'd have to know which menu option it'd be to enable this. And again, it's not too difficult. Injection preventions, whitelist accepted commands, avoid using any type of dynamic data for system processing. Validate input, output, encode characters, and you can use either Burp Suite, Zap, or something called comics. Anybody use comics for command injection? It's almost like a SQL map for command injection, so you can even find what's called blind command injection. So you can't see the response, but you can see, let's say, based off a ping, on a listener that there is command injection. And these are super, super common. Again, and I'll go through an example in just a second, but for that personalized botnet, what they're exploiting is a command injection within an FTP function for an IP camera that's used not only on the DVR, but on the cameras themselves. And even not only cameras, they're even smart door locks as well. They're using the same firmware, same exact firmware. All right, let's try this. This is the one I'm gonna VPN home. All right, so I created a script for it, and then we'll go through what the script is. See if it works. Yes, it works. Okay, we're getting a response. So I'm command injecting that same example here. Right here, instead of doing the ping, I'm actually, we'll see if it responds. No. It's funny, I tried it 3 times when I was waiting in the back. Oh, there we go. Now we're in a shell. Here we are, root. And what do you know? Let's just even look here, because there's also a hard-coded password. What do you know? So what this is, again, command injection, basically dropped it into a shell without any username or password. I didn't even use the credentials here. And the reason for that is, now what this uses is for FTP. Now this is going all the way to LA, so let's see how. It's obviously not going to be as fast. It basically inputs, blindly accepts these arguments here. This telnet, I just basically opened up telnet, port 25, dropped it into a shell without a username or password. Super, super simple. Let's look at the script really quick here. Come on, exit. Let's open up another shell. So all it is, again, for the password, just literally just bash here, open it up, starting telnet on port 25. And all I have to do is, again, it's going to open up just to a shell command. And in order for the setting to save, you have to call this script here, this CGI. And it's funny, it also has the username and password in the URL. So there's that. So again, these IP cameras, in the keynote, they're Swiss cheese. But it's fun to get some reverse shells over command injection, like using, if you could get a limited or like let's say netcat or even Meterpreter. I have not tried Meterpreter yet. But again, very, very simple, very, very common. There's my live demo. And basically how this looks as far as code's concerned is having a dynamic value, again, that's not escaped, not validated. Oh, something happened? Oh, cool. So just looking at this piece of code here, we have the any command that is dynamic, that is being executed by system here. And you can see the command buff. Right here is what calls this any command. What you can do basically to execute this system command is basically add, write whatever parameter and then add a user as an attacker. Again, simple, not validated, not escaped at all. As far as firmware, this is a sore topic for a lot of people, and even manufacturers from the consumer space, the regulated space, and even again, commercial ICS, and even consumer as well. But you always want to update over TLS, have it automatic or scheduled updates. With the caveat of medical devices, again, pacemaker, for example, you can't just update a pacemaker in the middle of usage. But force updates, again, aside from medical devices, in certain scenarios. And this happens in consumer space right now. I know for DVRs, this is happening since Mirai. Manufacturers who weren't affected by Mirai have taken steps to make sure they're not going to be affected in the future. Even if you buy a new DVR from a number of different DVR makers, that they'll force update before you even use the device, as well as the cameras. So they'll make you update the device before using it. And also even downgrading, having some sort of anti-rollback protection, not letting old vulnerable firmware be loaded. And again, this is actually dependent on the license that's being used on the device. So if it's GPL, it has to be kind of open. You have to release a source code. So let's say Linksys devices, for example, GPL. You can load your own firmware, but you have to know the drivers that are compatible with the board, which they do release, by the way. But again, that's dependent. Not everybody follows those licenses, unfortunately. And again, maybe it could be different reasons, proprietary reasons. That's arguable. But you definitely want to cryptographically sign your updates and validate and verify that the firmware did come from a trusted source, like a manufacturing OEM source and server. And even from the public key, the root chain as well, is what you want to validate. This is something we did at Balkan as well for updates, and that's one of the things we got slapped in the hand for by researchers was hard coding. I didn't know about this. I walked into it, hard coding a GPG key, private key, in the devices, so you can basically upload any type of firmware. So that was kind of a pain point there, but again, we'll discuss some more other painful things that happen. But you also want to include some changelog details about security-related vulnerabilities, and people are getting better about this. And again, even in the IoT industry, and when I got started 3-4 years ago with Balkan, again, like Kino was saying, there wasn't much out there, but now we have a bunch of researchers. It's a playground for all of us, really. But to include these, security fixes and give credit where it's due, definitely that helps the community as a whole, and even incentivize researchers. That's kind of self-explanatory. Firmware versions are clearly displayed. But storing this data and how you're going to store it and not basically hard-coding values, tokens, passwords, PII data into firmware images. And again, this is also common, unfortunately. But when you do have something sensitive, store it in, let's say, a secure element if the device is, say, more regulated. Maybe it's an ICS device, definitely should have some sort of capability to do so. Consumer device, again, the argument between 1 cent and 20 cent and margins, it doesn't make as much sense for them. But still, it doesn't have to be saved on disk. And don't store it in unprotected locations. Unprotected locations like SD cards, for example, flash, or the EEPROM. EEPROM is basically an 8-pin chip. You can basically take it off board and pull all the contents as well. And you have a hard-coded value here. This is one by D-Link that basically bypasses authentication if you send this user agent header. So don't do that. But again, if you find the firmware, like I said, it's half the battle. If you find something like this, simple, right? I mean, you know what to send, you know what to try, you know what to test. So similarly to any, whether it's mobile, whether it's any thick app, any type of reversing, you always want to statically analyze first, and then validate and verify what you see statically, dynamically. So whether that be, when the device is running, in other terms. So who got slapped in the hand again is D-Link. Not only D-Link, this is by FTC, but also ASUS got slapped in the hand. So this is something that's different. They're getting fined, and they're also mandated to perform pen tests for the next 20 years. This hasn't happened in the consumer space, especially in IoT consumer space, for not doing their own due diligence and advertising false sense of security and easy to set up, and also having insecure defaults and putting people at risk. And I actually showed this backdoor account here, and it's probably the demo 3. And this backdoor account was the one for Perseri. And I believe I have, did I crack it? Did not crack it. I do have the cracked password, though, and it's online, available as well. And this just released, actually, in March, late March. And again, it's being exploited. And I think 2 weeks ago, even there was a whole case study done on it by Trend Micro, if you want to have a look at Perseri. and these exact camera vulnerabilities, and you saw how easy they are to exploit. And again, those are the camera vulnerabilities that use your network to open up a port that external third parties for the camera can view your camera feed even. And I say it that way because the same camera has like 10 apps and three different cloud providers, and somehow, I don't know, and they're different infrastructures. One day AWS, one's like a cloud provider, a hosted cloud provider, but they all have my credentials. So I don't know, it's really weird, decentralized, and very scary at that, how they all kind of work together, OEM-wise or ODM, or their cloud providers. So your camera feed is being seen by a lot of people. So if you do the research on a DVR or a home security system, make sure to check whether there are external applications that can have access to your camera feeds and with authentication or unauthentication, because chances are there are multiple apps, multiple web applications that can access your camera, and again, without opening ports at all, which is the most scariest part here. And this kind of leads into like identity management and separating of accounts between external and internal users. But again, at this point, what's the difference between external and internal when you're traversing networks and routers and firewalls? But I mean, some sort of due diligence for your session IDs and tokens and session storage. Again, all day you'll see in an embedded device, even if it has a mobile app and no web application, they're sending their session ID over a GET request. And you saw just like the admin example, and even mature, I'd say doorbell or door locks even do the same. They think you're not going to proxy the traffic, or they're using SSL, so it's not possible to man in the middle. But as researchers, we have ways around that, and you can see that these session IDs and tokens that do not expire, even if you log out or change the password, are being sent over the URL. So again, we want to put some guidance, and again, there's specifics as far as how to do this right within our the guidance document, the Git book that I discussed earlier. And if you're going to use an EEPROM or a UART, I'm sorry, which is a serial interface, hardware interface, basically that manufacturers use to validate configurations on devices. So it's sometimes required in order to see whether a device is configured correctly. So this is why this is on there. Even I know we tried to like cover it up and put some other pieces of the board on top of it, but again, it's just defense in depth is the idea for embedded in IoT in general. But what we did for Balkan, for example, we put a 32-character password for UART. So have fun trying to attack that, alphanumeric special characters. So trying to influence the industry and move towards that direction rather than password 123 or 123456 for UART passwords, because sometimes they will have passwords, and it's just as simple as that, 123456. And it's funny, I mean, embedded framework hardening, this is basically Linux hardening, but for either BusyBox and services that are running on top of BusyBox, and again, just general Linux as well, but even cleanliness, like langsec, for example, remove unused code and libraries. And sometimes developers and manufacturers already do this because the storage where this code base is being run from is very small. But if they have enough space, they really don't care. It's almost like the Android, accept all permissions for frameworks with Cordova, as an example. But again, you want to move dead code, libraries, services that are being used, as well as shell interpreters. But definitely take out these legacy vulnerable daemons, FTP, Telnet, and iterative threat models. Again, I'm going to keep harping on threat models because I think it's super important and crucial in order for us to get to a place where we need to be. And again, basic threat modeling. You just need to spend one day and going through an exercise on threat modeling. So here's an example of enabling just bash. And I have seen bash, dash, and ZSH enabled on one embedded device. And sometimes they think that they took it off during development, but it's also just being pushed in production. So simple, and this is build root again. So it's menu config. And you can also, I'll get to that in just a second, but for example, taking off FTP here and enabling something like SSH. And there's the same menu configuration for the kernel as well. So if a company is going to build their own kernel, it's called kconfig. It has the same drop-down menu as well. where you can modify your kernel. So debugging code and interfaces, and this is more speaking towards like the root passwords and hard-coded credentials that cannot be changed. And again, yes, admin is a problem, admin password is a problem. But again, it stems from the ODM and the supply chain aspect of how these devices are made and created. And unfortunately, it's so common where we see these debugging interfaces, encode and backdoors within devices, libraries, and SDKs. And again, what we try to work towards, and this is something again from what we did over at Balkan and Linksys, was have some liability put on the ODMs, forcing them to have someone on staff, security-wise, and then provide security updates for a number of years, 6 years, whatever it may be, or until the device is deemed end of life. And that's depending on the manufacturer when they want to state a device's end of life. But again, right now there's no liability. The ODMs are gone, like I said, in 3-5 years. But if you put some sort of contractual agreement, you have, I guess, some weight to pull from that aspect. And nothing. And again, the IoT space and consumer space, definitely, there's no regulation. You have like self-certification or using something like UL 2900, which is new. But again, it's more of a pay-to-play type of organization and test where it's very closed. Like I don't know what test is being run, and neither does the manufacturer as well. But again, super common. And usually what they do is basically run a series of tests and like unit tests and just check marks. And they're like, oh, looks good to me. I've seen this literally. So like, this is Stevie Wonder. Stevie Wonder's blind, so they're not even looking at it. So when you have like the Windows certification, Zigbee, Wi-Fi, OS X, and you have little stickers on the boxes, all they are just unit tests, and that they're automation tests that the QA team runs. And literally, if you go into a QA lab, it's just like check, check, check. They don't even know what's running. And the same thing similarly to like UL 2900, for example, is probably another different form of that. But it has to be in an automated fashion in order for these devices to be mass-produced. But again, no one's really looking. And again, we have to keep up security automation-wise for making and deploying these devices. But yeah, they're not looking at security as far as that's concerned. And this is an important part, third-party code and components. Have a bill of materials, what libraries are being used, what software, inventoried out. I believe, I forgot the exact standard that's pushing this, but in China, they're requiring this for manufacturers to have a bill of materials. I think it's for the medical space, either medical or IoT, but definitely I forgot which standard it is. They're requiring OEMs and manufacturers to have a bill of materials. But when you have a bill of materials, you know what software is running, you know what versions. Check against vulnerable databases, NVTs, and also use free tools. Again, these devices are heavily JavaScript as well. There are a number of different libraries, whether it's front-end JavaScript, you can use retire.js, you can use NSP for Node.js, Linus for operating system hardening and kernel hardening and guidance on securing services as well. And then for dynamic testing, you can use free tools like OWASP Zap. And even have APIs and automation you can input into, let's say, your agile CI environment. And this lib scanner here for Yaak, this also has like an XML output where you can use these tools inside your environment. And we'll give an example right now. It just basically scans your packages and your package numbers. But also, you want to utilize package managers. Now, everyone's heard the term of reflashing or re-updating or a device. In order to update a piece of firmware, you have to flash the whole device. It's not necessarily true. You can use a package manager, and if you're familiar with, any type of small embedded device or a Raspberry Pi or even like Wi-Fi Pineapple, they have package manager, IPKG. You can also utilize that, but as far as manufacturers are concerned, they'd have to do some testing because a lot of dependencies in embedded devices that you wouldn't even think about, even like SQLite will extend out to another third-party service you wouldn't have any clue. But it's definitely possible. It just takes some testing. So here's lib scanner. Basically, it's for Yaak. Point it to the install packages, and it queries for CVEs, and it gives you the output and the severity, and if it failed as well, when it was published. So test cases. We need to have some sort of automation for this space to improve. And again, threat modeling. It's important. I mean, a basic methodology to threat model IoT devices, and generally any sort of application, but you have to identify the assets, you have to create a device architecture overview, decompose the device, identify the threats, document the threats, and rate the threats. So stride, dread, I'm not going to go through those in detail, but just so you have an idea as far as the workflow to threat model these devices. And here's an example of the firmware of just taking inventory of the firmware and the libraries that are being used. It might be a little small, but like HTTPD, DNS, OpenSSH, libupmp, some DVR config files, logs, operating system config files. Even again, this is embedded Linux with the bootloader. Just taking a basic overview of the assets, and then here's an overview of device functionality, like how the device functions when you save, let's say, a video. Again, this is using a DVR is what I created. You have raw data feed using RTSP, the DVRs and the LAN using your trust boundaries, internet boundaries, the cloud, ICE and stun server, Android application, but also how it's being used, creds and camera recording stored in mobile devices. So how the functionality of the DVR or the device or the ecosystem in which it's deployed in. So again, it's context specific. So this is for, let's say, small businesses. This could be for consumer. But for more like medical, for example, would have a different layout as far as the impact and the safety and the privacy concerns as well on the analysis on those aspects of where the device is being deployed. But here's another example of just renaming and using RF, like how the device communicates radio frequency-wise, if it's Wi-Fi, if the mobile application is using 3G, 4G, if the application is using HTTP, TCP/IP, things like that. So again, you want to rinse and repeat. You want to continuous threat models updating. I did, for example, updated this threat model to the RF side and move things around accordingly. So it's very important to do continuous threat models, even from an attacker perspective, before you get started. Continuous testing, whether that be statically, dynamically, interactively, or pen testing as well. Update as much as possible from the consumer standpoint. And if you can, again, update automatically. A lot of devices do have that functionality. And if you're reporting bugs to any of these manufacturers, reference a disclosure policy like ISO 29147. This is something that's the bug bounty programs use as well. Platforms like BugCrowd, HackerOne. Actually, I think Katie from HackerOne helped create this disclosure policy here. But also influence the involvement in the community and point the manufacturers, the vulnerable manufacturers, and basically enlighten them to what other manufacturers are doing and how they're getting involved. That's usually what I do. So like the car research, I referenced how like Ford and other car manufacturers are and Fiat are using, and Chrysler are using bug bounties while Subaru didn't, for example. And they were enlightened as far as, okay, well, now we can have some sort of starting point and using something like I Am the Cavalry's five-star program as a baseline. So again, just enlightening them, involvement in the community is the idea. And some closing thoughts here. It's still a 0 day if they didn't update it, technically. Let's keep breaking things. I know for us over in the States, FTC, basically, we are DMC exempt for security research now if you rightfully own the device and perform the research under a controlled environment, and if the research happens after October 28th, 2016, so it's way past that. So just think about how that wasn't possible with jailbreaking devices and even circumventing like Xbox, for example, but now we can. Let's keep doing it, and I'll help you. If you want to hack, can I cuss here? Want to hack some shit? Let's hack some shit. Thank you, guys. My name is Aaron. My email is up there. Cheers.
Thank you, Aaron. That was great. I think we have time for 1 or 2 questions. If there's any hands in the crowd, right here.
When it comes to stack protection, is there any reason why you would have that
box not checked?
That's exactly what
Does
I'm
it
saying.
just default to on?
No, they don't.
Oh.
That's the thing. We have to have more secure defaults, but no, it's not a default in the build systems, unfortunately. And Yaak is more. It's not a build configuration like build root. As far as menu configuration like build root, it's more. You have to put manually input the configurations in there and secure compiler flags, GCC compiler flags.
All right, over here. Okay, let's see.
All these IoT devices, how do they usually connect to the internet? Are they connected outside the router, or is it like are they opening up the router so you can connect into them?
Yeah, that's the exact. Basically like a reverse tunnel. Think about it that way. Like a hybrid cloud. They're using a device inside your network to call out to their cloud environment to open up that port, open up a pinhole, and think about voice over IP systems. This is how they work. With UDP, and they are UDP tunnels, like that P2P bot, the Perserai, is using a UDP tunnel, and keeping up. And this is more common in small business and consumer routers. That functionality, where you can open up a pinhole without port forwarding from inside the network. It uses something called UPnP IGD, internal gateway device. Is what it's called. So very scary, but yeah, calls from in your network, opens up a port. Reverse tunnel is what I see it as.
Thanks, Aaron, for a good talk. The ODM issue is a liability and supply chain issue. Do you see that these ODMs are now going into bug bounty situations and disclosure policies as well?
No. ODM side, not at all. Definitely the OEM side, there are manufacturers that are going through bug bounties and being more open to that, but ODM side, they're small teams. They have no incentive. They don't have any contractual agreements either. But I have not seen one ODM participate in the community at all, unfortunately.
All right, unfortunately, that's all the time we have for questions right now. So please put your hands together once more for Aaron. That was a great talk.
Thanks, everyone.
And we'll have our next speaker on stage in about 10 minutes. So if you do want to get some coffee, please do, and be back here in 10 minutes.